So hi everyone. So I am going to explain you about the experiment on Curie temperature. Aim of the experiment is to determine the Curie temperature of given material. So the apparatus required are CRO, digital voltmeter, thermocouple, primary and secondary coil. So the theory of this experiment is the Curie temperature of a given magnetic material makes a transition from ferromagnetic to the paramagnetic state. So as I said, the apparatus required for this experiment are CRO, digital voltmeter and the primary and secondary coils. So here we can see the primary and secondary coil. So we have to mount the specimen between primary and secondary coil with the help of thin hole thermocouple, and we have to connect the output of the secondary coil to the CRO. So here the channels they have given, across any one of the channel we have to connect the output of the secondary coil to the CRO, and the thermocouple ends to the digital multimeter. So here we have to include digital multimeter also, and then we have to heat the specimen with the burner. Here the between this primary and secondary coil, the sample, that is nickel, we have to heat with the burner. So here is the diagram for this experiment. So the primary and the secondary coil wound over the iron core, and the sample here is the nickel. We have to keep in between the primary and secondary windings, and we have to heat with the burner to the sample, and we have to connect the output of the secondary coil to the CRO, and the thermocouple to the DMM. So we have to note down the voltage across the digital voltmeter, and then we have to put values in the tabular column. We have to note down the observations here. Room temperature 31 degrees Celsius, thermocouple used chromel alumel, and the correction voltage, thermocouple voltage corresponding to room temperature we have to note down first before starting the experiment. Once we make the connection, room temperature, we have to note down the voltage 1.2 millivolt. Then given sample, as I said, nickel. Sample is nickel, thermocouple is chromel alumel, and corresponding room temperature voltage we should note down. So here is the tabular column. First we should write the thermocouple voltage from the digital voltmeter in the increasing order 0 to up to 15 volt, but this is the voltage for room temperature. So we have to add the correction voltage to this thermocouple voltage 1.24 every time. 1 plus 1.24, 2 plus 1.24, like that we have to add and write this column. Next, temperature corresponding to thermocouple we should note down from the voltmeter, digital voltmeter. Then temperature we have to convert in terms of Kelvin, and secondary coil output we have to write here from CRO. So up to 18 volt you can take, and this is the graph. We have to plot the CRO input voltage versus temperature. If we plot the graph of CRO input voltage, that is from the secondary coil, versus temperature, then we will get the curve here. So from that we can calculate Curie temperature, that is T1 plus T2 divided by 2. That the Curie temperature is about 605 Kelvin. So from Curie temperature we have to calculate two more parameters here. First is exchange integral. Using this formula, substitute all the values, you will get the value about 3.27 millivolt. Next, go for the Vis molecular field constant. So substitute all the given values. So the lambda value is about 3.5831 into 10 to the power 3. At the end, write the result: Curie temperature of the nickel, exchange integral, Curie Vis molecular field constant.